Bismillahirrahmanirrahim. Welcome again. Now we are in the second part of lecture number 7. If you remember, we just did 3 examples in part A. So now I am continuing with few similar examples. So let's have another example. This is, let's say, example number 4, and now I have to evaluate. Let's say I have these 3 integrals over any region R, and I have x square plus y square plus z square, and I have dx, dy, dz here, where R is the region, where R denotes the region bounded by, where R denotes the region bounded by x equal to 0, y equal to 0, z equal to 0. Let's say we have these kinds of and x plus y plus z equal to a for all a greater than 0. So now I write an example in a word problem format. So we can draw its figure as well, but remember that in 3 dimension it is always difficult to draw a figure, and once we draw the figure then it will become much more confusing for you, because we have generally tendency of viewing each and everything in 2 dimension. So you feel a little bit difficult. So if you do not want to draw the figure, but even though it is possible to calculate the limits easily, just concentrate that how we are identifying these limits. So now I need to integrate this. So you look at these, that these are 3 limits here, one each of x, y, and z. All 3 are constant. So let's say if I like to do with respect to z first, so I need the second value of z. So I can easily find the second value of z from here, a minus x minus y. Let's say I want to do integration with respect to z first. If I want to integrate with respect to y first, then I can easily calculate the value of y from here. Or I want to calculate with respect to x first, I easily want to calculate the value of second value of x from here. So viewing this example, it is up to us that whether we want to integrate with respect to z first or x first or y first by keeping these kinds of limits. So let's say we are trying to integrate with respect to z first. So now we have 2 limits of z. So just concentrating on 2 limits of z. So now z have 0 and a minus x minus y. I am not writing the above limits. I will write above limits once you understand the scenario. So at present I am just concentrating to focus on one limit of the variable. So now I am deciding that I will integrate with respect to z first. So one limit of z is 0 and other limit of z is a minus x minus y. So it will become much more easier for you. So now it means x square plus y square plus z square, and we will do with respect to z first, then with respect to y, then with respect to x. So let's say we want to do it in this way. So it means what will be the outcome? It will be x square z plus y square z and plus z cube by 3. This is the answer of the integration, and then we need to substitute the limits. Limits are 0, a minus x minus y. And then we will write the other integrals as well. These 2 integrals left. I will later on write the above limits. So what will happen now? That we need to substitute the upper and lower limit. So these are the 2 integrals. So for upper limit, this is the upper limit. So x square, upper limit is a minus x minus y, plus y square a minus x minus y plus a minus x minus y whole cube by 3. This is the upper limit. Then when we substitute the lower limit, which is 0, so 0, 0, 0, so all terms will be 0. So it is only dy and dx. So now we substituted all these values. So now it's time to see that what happened once we have the variable z eliminated from the equation. What will happen? So now once you have eliminated the z, so let's write that you have only z is equal to a minus x minus y. So again focused on this one. Focused on this one. Now z is eliminated, or substitute z equal to 0 here. You will have only x plus y equal to a, because now z is eliminated. You have calculated z. So elimination means now just feel that no z is there. So it means mathematically z is 0 there. So I substitute sorry. So I just write it again, this term x plus y equal to a, just two dimensional. So from here y is equal to a minus x. So it means the set y now have limits a minus x, a minus x, a minus x. So it means now we will write this term as so if I write it as, because it will be easier to calculate this one, so it will be better if I write it as ax square minus x cube minus x square y plus ay square minus xy square minus y cube, and then we have plus a minus x minus y whole cube by 3. So then this will be straightforward to integrate. You will feel much more comfortable in this situation. So this is a minus x, this is 0, and this is 0. So now we will integrate with respect to y. So it means both these are constant. So ax square y minus x cube y minus x square y square by 2 plus a y cube by 3 minus x y cube by 3 minus y 4 by 4, and plus the derivative of whole this term is minus 1. A minus x minus y whole cube, the derivative of is minus 1. So I can write minus 1 here. So it means a minus x minus y power 4 upon 4 and minus 1. And 3 is also there. So it is better to write it again, because it is not clear to you in vision. So I am writing it again. So this is a minus x minus y whole power 4 upon 4, and the derivative is here minus 1. And then we have the limits, and limits are 0 to a minus x, and the rest is, what is rest is the integral of x. This is dx. So now we will substitute the upper limit as well. So the upper limit is ax square, and upper limit is a minus x cube a minus x square by 2 a minus x square plus a by 3 a minus x cube minus x by 3 a minus x cube minus a minus x whole power 4 by 4 and minus 1 upon 12 a minus x minus, if I substitute in place of y, a minus x minus a minus x, so a minus x minus a plus x, so it will all be 0, and then when we substitute, so upper limit will be 0, 1 upon 12, upper limit will be 0 on substituting, and then minus the lower limit. So lower limit will be, no, this is not the time to write lower limit, this is the upper limit. We at present we are substituting all upper limit. Then comes the minus sign and then the lower limit. And what will be the lower limit is 0. So when we substitute here 0, 0, 0, 0, 0, 0, but here we do not find any 0, because when we substitute 0 here, it will be a minus x whole power 4 upon minus 12. So it means we will only have a minus x whole power 4 upon, this will be automatically becomes plus, because with negative sign we have this one and this one. Please look at this very carefully, because it is important to understand that how I am substituting the limits. Because if I am making any mistake in it, then if we look at carefully, then it will be easier for you to highlight that mistake. So now it is important to simplify this step to integrate with respect to y. So now I simplifying this. So what will be the first term? Will be a square x square, then we have minus ax cube, then minus ax cube, minus minus plus x power 4 minus ax square by 2 minus, no sorry, minus x square by 2, and we have a minus x whole square means a square plus x square minus 2ax. I open this one because I need to multiply this one, plus a upon 3 a minus x whole cube minus, then we have x upon 3 and a minus x whole cube, and then minus a minus x whole power 4 upon 12 and plus, no, minus a minus x whole power 4 upon 4 and plus 1 upon 12. So 1 upon 12 minus 1 upon 4. So 12 LCM. So 1 minus 3. So minus 2 upon 12 means minus 1 upon 6. So minus 1 upon 6. So I added both these terms. So then it becomes much more easier. So minus 1 upon 6 plus 1 upon 12 minus 1 upon 4. Okay, so this will be dx, and we have the limits of x as 0. Then what will be the upper limit? We left with x plus y equal to a. So it means now y is also finished. So y is 0. So x equal to a will be the upper limit. So the upper limit of this will be x equal to 0 to a will become the final limits of this one. So now again integrating all these, so we have a square x cube by 3 minus ax4 by 4 minus ax4 by 4 plus x5 by 5 minus, and what will happen in this, I am showing you that this is 1 by 2, so a square x square plus x power 4 minus 2ax cube. So this is the term, so I am integrating accordingly. So a square x cube by 3 plus x power 5 by 5 minus 2ax power 4 by 4. So first I multiplied this one and then integrated. Then plus a by 3 and this is a minus x power 4 by minus 4, because the derivative will be minus 1 and then power 4 by 4. Then minus 1 by 3. What will happen in this one? This is important to understand because there are two possibilities. I can open the cube and then multiply x with this one, or I can apply u into v, because I have x into a minus x whole cube dx. Okay, so if I try u into v, yes, it is possible. So it means I can write u into integral of v 4 upon minus 4 minus integral derivative of u and into integral of v. So it means we have x a minus x power 4 upon minus 4 minus minus plus 1 upon 4. And again integrating, this will give a minus x power 5 upon minus 5. So it means I will find that this will be equal to x a minus x whole power 4 upon minus 4 minus 1 upon 20 a minus x power 5, and we need to substitute the value 0 to 8 in whole. So now substituting the limits, in this scenario, what will happen? If I substitute a first, it will be a power 5 by 4, a cube into a square, then minus a into a power 4, a power 5 by 4, sorry, this is 3, minus a power 5 by 4 minus a power 5 by 4 plus a power 5 by 5 minus 1 by 2, and then a power 5 by 3 plus a power 5 by 5 minus 2 a power 5 by 4 plus a by minus a by 12, because this is the constant a by minus 12, and then if I substitute a, this will be 0, then minus plus 1 by 12, I open this bracket. So in place of x, if I substitute a, and this will be 0 power 4 minus plus 1 upon 60, and this is also 0 power 5. This concludes the upper limit. Then minus the lower limit. So what will be the lower limit? This will become 0, minus 0, minus 0, plus 0, minus 0, minus 0, plus 0, 0, 0, 0, and then minus a upon 12. This is a upon minus 12. So a minus 0 means a power 4 means a power 5. This is a power 4 into a power 5. Then minus plus 1 upon 12 here. Then we have 0. So whole term will be 0. Then minus plus 1 upon 60. and then is 0, so a power 5, and finish this one. So now we need to add all these terms. This is 0, this is 0, this is 0, so these three terms are 0, this is also 0. So what we left is a power 5 by 3 minus a power 5 by 4 minus a power 5 by 4 plus a power 5 by 5 minus a power 5 by 6 minus a power 5 by 10, 2 5s are 10, and minus a power 5 by 4, sorry, minus plus a power 5 by 4, 2 cancels with 2, so this is minus, and this is plus, then these are cancels, then minus plus a power 5 by 12 and minus a power 5 by 60. All terms have a power 5, so I take a power 5 common, so what is left is 1 upon 3 minus 1 by 4 minus 1 by 4 plus 1 by 5 minus 1 by 6 minus 1 by 10 plus 1 by 4 plus 1 by 12 minus 1 by 60. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 by 4 cancels with 1 by 4. So now what is required is to take an LCM. If I take 60 as LCM, so 3 it means 20 minus 15, then 5 plus 12 minus 10 minus 6 plus 5 minus 1. So it means I have the number 20 plus 12 plus 5. 20, 32 plus 5, 37. Minus 15 minus 10 minus 25 and 6 minus 31 minus 32 upon 60. It means 5 upon 60. It means 1 upon 12. So it means I finally have a power 5 upon 12 as the answer. A power 5 upon 12. 60 will be the LCM. So 20, 60 will be the LCM. I mean, yes, I am correct. So this is a power 5 upon 12. So please do check the calculation as well. If you find that there is any mistake in addition and subtraction, please do highlight and correct it as well. So I feel that if I not made any mistake in addition and subtraction, then this will be the final response. So let's move on to solve at least one more example in this context. So let's solve one more example before ending this part. So one more example in this context is this one. Let's say I have an example like this, that compute the integral, triple integral dx, dy, dz over x plus y plus z plus 1 whole cube, x plus y plus z plus 1 whole cube, if the region of integration is bounded by, if the region of integration is bounded by what is needed by the coordinate planes the coordinate planes and the plane x plus y plus z equal to 1. This is almost identical kind of example as I did now. Why? Look at the solution. The coordinate planes means the coordinate planes are x equal to 0, y equal to 0, z equal to 0. These are known as coordinate planes. And then we have x plus y plus z equal to 1. So again you have the identical scenario that you have one limit of each variable and you have to take the limits from the plane of x plus y plus z equal to 1 from here. So again it is up to you that which variable will be integrated first. Let's say we will try to integrate with respect to z first. So it means the limits of z will be 0 and 1 minus x minus y. Then we have 1 upon x plus y plus z plus 1 whole cube dz dy dx. So integration of z will be tried first with respect to dz dy dx. And what will happen? Here we have 0, here we have 0. Once z will not be there, then we have y equal to 1 minus x. The second limit of y is 1 minus x. And if y is also not there, the limit of x will be 1. So we have 0 to 1, 0 to 1 minus x is 0 to 1 minus x minus y. So what is the integration of this with respect to z? We will move into, this is minus 3 plus 1 minus 2 upon 2. So we have 1 upon minus 2 x plus y plus z plus 1 whole square. And the limits are 0 to 1 minus x minus y dy dx. And then we have 2, 0 to 1 and 0 to 1 minus x. So this will be the response of the integration, and now it is needed to substitute the upper limit and lower limit in place of z only, because these are the limits of z. So I am doing it here roughly. The term is, keep 1 upon minus 2 outside. So for upper limit 1 upon, for upper limit there is x plus y plus 1. I am writing 1 first, and then plus z. Z is 1 minus x minus y, 1 minus x minus y. So x cancels with x, y cancels with y. So this is the upper limit minus the lower limit. So x plus y plus 1, and now z is 0. So what left is 1 upon minus 2 and then 1 upon 2 minus 1 upon x plus y plus 1. So this is finally we have. So if I take minus, this is minus 1 upon 4 and minus plus 1 by 2 and this one. So this is what we have. This is the upper limit minus lower limit. So what is needed is to integrate 0 to 1, 0 to 1 minus x, and I have 1 upon minus 2 outside. No, plus 2, this should be, because minus 3 in the numerator plus 1, yes, minus 2. and then I have here 1 upon 2 minus 1 upon x plus y plus 1 dy dx. So now integrating with respect to y, so I am writing 1 upon minus 2 here, this is 0 to 1, so 1 upon 2y minus, the derivative of y is 1 there, so minus log of x plus y plus 1, and limits are 0 to 1 minus x dx. Because this is constant, so y and the derivative of x plus y plus 1 is 1, which is in numerator. So now substituting the limits, 1 upon minus 2, 0 to 1, so half, this is 1 minus x, upper minus lower. Then from here minus log, minus here, and then substitute minus log x plus y plus 1, x plus 1 plus 1 minus x, so x cancels with x because we need to substitute in place of y. So this is only log 2 minus log of, now substituting 0, so this is x plus 1 dx, because lower limit of y is 0. So now ending this question, so this is 1 upon minus 2, then integral 0 to 1, we have 1 upon 2, 1 minus x minus log 2 minus minus plus log of x plus 1, and this will be dx. So 1 upon minus 2, and now we are integrating this term, so 1 upon 2, the derivative of 1 minus x is minus 1, which we can write, so 1 minus x square by 2, then minus x into log 2, and then plus, so log of x plus 1 means we need to use by parts formula for log of x plus 1 dx. So this will be u and v, so u into v is x minus integral derivative of u into integral of v dx. So this is equal to x into log x plus 1 minus, if want to integrate x plus 1 minus 1 upon x plus 1 dx. So this will become minus 1 minus 1 upon 1 plus x dx. So what we have, x into log x plus 1 minus x minus minus plus log of 1 plus x. So it means we have plus x into log x plus 1 minus x plus log of x plus 1, and then we have limits 0 to 1. So finally, writing all these terms carefully, so on substituting 1 upon minus 2, on substituting upper limit 1 upon minus 4, 1 minus 1 is 0, then minus 1 into, this is log 2, plus log 2, because 1 here, minus 1 plus log 2. This is upper limit, then minus the lower limit. So when we substitute, so I am writing lower limit here. So minus lower limit means 1 upon minus 4 for this term. No, I will write minus 1 upon minus 4. 1 minus 0 is 1. 1 square is 1. Minus 0 plus 0 minus 0 plus log 1. So what I left is 1 upon minus 2, then this term is 0, minus log 2 plus log 2 cancels, so minus 1 plus log 2, then minus minus plus 1 upon 4, and then log 1 is 0, because log 1 is 0, so there is no need. So finally we have 1 upon minus 2, and then 1 upon 4 minus 1 is minus 3 upon 4 plus log 2. So if I multiply it with this one, I will find that 3 upon 8 minus log 2 upon 2. What I find is 3 over 8 minus 3 over 8. I find that this is 3 over 8 and log 2 upon 2. So this concludes this part. So hopefully you will find these examples very suitable for understanding. Inshallah, we will continue with the third part of these examples in next session. So it's goodbye now.